Chapter 7, number 21. The energy required to increase the speed of a certain car from 18 meters per second to 24 meters per second is 190 kilojoules. What is the mass of the car, and at what speed is the car's kinetic energy equal to 190 kilojoules? So, the picture is going to be kind of fast and basic. We start with our car, and it's moving with an initial velocity that is 18 meters per second, and then sometime later it's moving with a final velocity that's 24 meters per second, and what we're looking for is what is m. The energy required to increase the speed is the change in kinetic energy. So we're going to say we have that delta K is 190 kilojoules. So 190,000 joules. Alright, but delta K is a half mvf square minus a half mv initial square. And I can factor out, I guess I can factor out a half m, and it's vf squared minus vi squared. And so I can solve that over, and I can say that m will be, well, we'll multiply by 2, and we'll divide by this difference in squared speeds. But then I have to do that up here as well. And so I get 2 delta k over vf squared minus vi squared. So 2 times 190,000 joules over 24 meters per second square minus 18 meters per second squared, which turns out to be 1,507.9 kilograms. And based on our 2 sig figs, and actually every place, this is really 1,500 kilograms. For part B, we're just going to say I need the kinetic energy to be 190 joules, but the kinetic energy is 1/2 m times the speed that I care about. So we have that the speed squared that I care about is twice the kinetic energy over the mass, or the thing that we want is the square root of 2k over m. Square root of 2 times 190,000 joules over this 1,500 kilograms, and we get 15.916 meters per second, which rounds to 16 meters per second.